All right, fantastic. All right, we're going to do these one column at a time. There are a couple questions in the Jeopardy game that actually deal with microscopes. You're not going to have any test questions on that. I'll leave them in the game because some of you guys remember some things about microscopes when you watch the video, or you have some experience with microscopes. Okay, without further ado, your first Paulus Jeopardy review. Here we go. Oh, by the way, keep track of the number of answers that you knew or that you think you would have known if it was on a multiple choice test. And when we get to the end, I'll say, okay, if you're in between this number and this number, you're golden. Take a couple days off. You're already ready for the test. Plus, you get to use your notes. Are you kidding me? And for people that have like a smaller number, I will encourage them to study a lot over the coming days. All right, here we go. To suggest that the presence of water could accelerate the growth of bread mold is to make a what? If you think you know what the answer is, put your hand up. And as soon as I have a good number of kids with their hand up, I'll show what the answer is. To suggest that the presence of water could accelerate the growth of bread mold is to make a blank. This would probably be in section 1, 2 notes. David, your mic is unmuted. I got about 10 or 12 of you guys. Anybody else think they know what the answer is? Remember, Jeopardy is a lot harder than the test because multiple choice tests, you can actually see the answer. You just have to pick the right one. So if you do really good in Jeopardy, you're probably going to ace the test. Anybody else want to put their hand up? They think they know what it is? Don't raise your hand unless you do think you know what it is. Okay, here we go. Correct answer is a hypothesis. It is a statement about an observation. The observation would be that you see mold growing on wet bread. So you could do an experiment to determine whether or not that actually speeds up the molding process by adding moisture. Good. Okay. So remember, keep track of all the questions that you get right, and we'll see how many you got right at the end. All right, next question. The following statements are all what? To investigate and understand the natural world, to explain events in the natural world, to use derived explanations to make useful predictions. Those are all what? If you think you know what those are all, put your hand up. If you were in class the day I taught you how to do reading notes, this would be at the very front of your reading notes. All right, guys, I'm going to see how this goes because my speakers are cranked and I can barely hear the music. So I'm going to turn it up just a tad. We still okay?
Yeah.
Good? Okay. Still okay?
Yep.
All right, cool. All right. All right, I got about 10. Oh, right on. I got about half of the class with their hand up. Got their hand in the air, waving it like they just don't care. All right, here we go. 5, 4, 3, 2, 1. Those are all goals of science. First key idea in chapter 1. Took notes on it in class notes. You took notes on it in the reading notes. Probably was a warm-up question. I'm pretty sure it was a warm-up question. All right, that was worth 1 point. If you got that one right, give yourself another point. All right, here we go. This is 3 questions, 3-point question. The statement that the bird has brown spots on its wings is a what? In the mineral density lab, what was the dependent variable, what type or types of data were collected? Remember, there's two types of data. There's qualitative and there's quantitative, okay? 3 questions. If you know 2 out of the 3 at least, raise your hand. If you know all 3, obviously, raise your hand. And if you're raising your hand a lot, take that hand and pat yourself on the back, because you still got 4 days to get ready for this test, and you already know a lot of the information. Cool. I've got half the class with their hand in the air. That's making me happy. Okay, about 15, 20 more seconds. Again, if you don't know what the answer is, try to find it in your notes. If you can't find it in your notes, at least find these questions on your study guide, so when I show you the answers, you can write them down. Oh, Rick Springfield. Unfortunately, when you're watching the video and studying later this weekend, you're not going to hear the music. Sorry, it doesn't work that way. It's being piped to you through Zoom. It's not being recorded by my video recorder. 10 seconds. All right, 5, 4, 3, 2, 1. Here we go. That is an observation. The bird has brown spots on its wings. Okay, in the mineral density lab, the dependent variable was what we were measuring. It was the mineral density. The dependent or responding variable was the mineral density. The independent variable was the type of mineral we were testing. Anything with units, grams per milliliter, density, milliliters, grams, pounds, inches, anything with measurements like that are quantitative data. Okay, that was worth 3 points, so you could be up to 5 at this point. Okay, section 1-2. A blank experiment allows scientists to isolate and test a single variable at a time. What type of experiment tests one variable at a time? Everything else has to be kept the same. Only thing you should change is an independent variable. And then you're watching to see what happens with the dependent variable. All the other variables are left the same. 10 seconds. 5 seconds. 4, 3, 2, 1. That is a controlled experiment. All right, we're up to 6 possible points now. Okay, here we go. Another 1-point question. Hands down, please. When enough data to support a hypothesis is collected, the hypothesis may become a what? So what is the next level of certainty in scientific thinking and understanding? Starts with a hypothesis. With data and evidence, it can become a something. With more data and more evidence, then it can become a something else. And then with more data and evidence, it can become a scientific law or a natural law. What's the next step over a hypothesis? And I'm pretty sure this was a warm-up question. Right on. I've got half of the class, about half of the class with their hand up. Somebody got kicked out. I'm letting them back in. By the way, if you ever guys ever drop out of a Zoom, just simply go log back in. Okay, when enough data to support a hypothesis is collected, the hypothesis can become a theory. All right, so we're up to 7 points right now. Some of you guys have all 7 points because I've seen your hands up every time. All right, if you don't have your hand up, don't worry about it. This is just practice. We still got 4 days to go. All right, 3-point question coming at you. Louis Pasteur is most famous for what disproving research? What did he conclusively disprove? Who did the previous work before Pasteur? Who did that experiment with the meat and the jars and the gauze? And what was the independent variable in that experiment I was just speaking about? Some of you guys are scratching your head and go, really? Can this test be this easy? Well, it's only easy if you're prepared. Okay, about 30 seconds. If you know 2 of the 3 answers, at least put your hand up. And what's cool about those of you that are putting your hand up, you're going to see your hands pop up in the video. So you can actually see who put their hand up first. Ten seconds. Okay, let me see how many people have their hand up. Right on. Over half of the class knows at least 2 of these 3 answers. Good. All right, 5, 4, 3, 2, 1. All right, here we go. Okay, Pasteur conclusively disproved the idea of spontaneous generation, the idea that living things can come from nothing. Salvador Redi was the person who started that research. He was the guy that did the jars and the meat. And of course, the only thing he changed in that controlled experiment was whether or not there was gauze or cloth on the jar. The type of meat, the type of jar, the size of the meat, the size of the jar, the temperature, the room, the time of day, all of that stuff had to be kept the same. Those would be controlled variables. And then, of course, the dependent variable in that experiment was whether or not there were maggots that appeared on the meat. All right, that was worth 3 points. Some of you guys are killing this. I like it. I like it. I like it. How many points are we up to? Let's see. We've got 6. We're up to a possible of 10 points. If you are 7 or higher, you are killing it. If you're 5 or lower, if you're close to 5, you're getting there. If you don't have any points, start raising your hand, looking up some answers, please. Okay, metric system and data presentation. Here we go. Blank plus a base unit make up the metric system. And I didn't actually give you guys notes on the metric system, but it's what kilo, hecto, centi, milli, deca, deci. These are all called something that goes before the base unit. And on the study guide, it said to go watch a video on it, and I am certain that it would have mentioned this thing in any video about the metric system. Oh, by the way, quick chance for a funny. Somebody unmute themselves and tell me why we don't use the metric system in America. Anybody? Why don't we use it in America? David, it's because we're what?
Because we want to be different.
Well, no, we don't have to try to do that. It's because we're Americans and we do things the American way. That doesn't necessarily mean it's the best way or the most efficient way or the smartest way. But yeah, we're Americans and we do things the American way. Everybody else, they use the metric system. We don't. And it's not because we want to be different. It's just because it's going to cost too darn much money to convert everything over. Come on, what do we call kilo, centi, all those things that go before the base unit? Anybody? I got about 7 or 8 of you with a hand up. Apparently some of you guys need to go watch videos on the metric system. I'll give you a clue. It's the 3-digit number that goes before your telephone number. So we're 916 or 530. It's also called that thing. 5, 4. Oh, speaking of phone number, Jenny, I got your number. Sorry, it was right there. I had to take it. Okay, we call that a prefix. Prefix. Kilo, hecto, milli, centi, deca, deci. They're all prefixes. Pre means before. Preseason, to precede, prelude. They all mean before. Okay? So find that definition on your study guide and write down this plus a base unit make up the metric system. All right, we're up to a total of 11 points. Here we go. 3 questions on this slide. A little bit of conversion. Okay, convert 0.007749 kiloliters to liters. A student makes a hypothesis about how plants will grow when playing different types of music. What is the dependent or responding variable in that experiment? And what is the independent or manipulated variable in that experiment? If you do not have the grid for converting in the metric system in front of you, pull out a piece of pencil. I'm going to tell you exactly what to write down. Far left, kilo, K-I-L-O. Next word, moving to the right, hecto, H-E-C-T-O. Still moving to the right. The next word is deca, D-E-C-A. Still moving to the right. This is where our base units are. Base units are meter, liter, gram. Still moving to the right. Deci, D-E-C-I. Still moving to the right. Centi, C-E-N-T-I. Still moving to the right. This will be the last prefix, milli, M-I-L-L-I. Oh, I got a joke. What do you get if you add milli with vanilla? You get lip syncing. Look it up. Sorry.
I was just about to say bad lip reading.
Bad, you got it. All right, here we go. Let's see, dependent and independent variables. Keep that grid. Have it available when you take your test. Okay, 10 seconds. 5, 4, 3, 2, 1. There we go. Okay, when you are converting kiloliters to liters, you are going from the left to the right. That's the way the decimal moves, okay? And we start here. We go 3 spaces to the right. 1, 2, 3 spaces to the right. So we end up with Yeah, we end up with 7.749 liters. Remember, there's a logic question that you can ask yourself to make sure you moved in the right direction. Kilo is larger than liters, so my number should get larger, and it does. Okay? So whatever direction in the grid you move is the direction the decimal goes, and how many spaces in the grid you move, in this case is 3 to the right, is what you do with the decimal 1, 2, and 3. Okay, in that experiment, the dependent or responding variable is plant growth. The independent or manipulated variable, the thing that you or I change, is the type of music, the amount of water, the temperature, the size of the pot, the type of the plant, the amount of dirt, the time of day, the time of watering, how much water, whether or not there's any fertilizer. All of those things are controlled variables. They have to be the same. So you know that if a plant grows more than another one, it was being exposed to rock and roll and not rap or country. Okay? All right, here we go. Okay, we are now up to 14 points. All right, here's 4 questions for you, 4 of them. Oh, never mind. It's actually only 2. Okay, so convert meters into kilometers. Convert kilograms into milligrams. See if you can quickly sketch this graph. You're not going to have to do a graph on the test, but you will have to look at a graph and will be asked questions about it. I'll give you an idea. The year is the independent variable, so the year goes on the x-axis. Population is the dependent variable, so population goes on the y-axis. So see if you can just do a quick sketch of a graph. You don't have to use a ruler. You don't have to use graph paper. You don't have to use a pencil, but do the conversions first. And this is not a 4-point question. This is a 3-point question. 1 for the graph, 2 for the conversions. Give you guys about 1 minute. Yeah, U2's all right, but they're not all that. Let's see here. Oh, yeah. Sorry. "30 seconds. And normally when we play Jeopardy in my classroom, it's quite an experience because I've got a 5-speaker surround sound system running off of a real stereo. It gets really loud. It's definitely the best classroom on campus to watch a movie in. But we're not in the classroom. And I play the music as background music so teams can talk and they don't have to worry about other teams hearing what their answers are. I tell everybody to cover up their answers because they're writing them on whiteboards. It's a lot more fun and interactive than this because it's competitive and kids can get extra credit points for their team winning. Hopefully, we'll be doing it at the end of the semester or next semester. 10 seconds. 5, 4, 3, 2, 1. All right, here we go. Okay, so the conversions. Okay, we're going from meters to kilometers. We are going left in the grid, left 3 spaces. So I move my decimal 1, 2. I run out of numbers. I add another 0, and we get 0.03287 kilometers. Quick way to check. I'm going from a smaller prefix to a larger prefix. So my number should get smaller, and it does. It starts at 32, and I end up with 32 100ths, okay? Here's what the graph should look like. The year, this is my correct x-axis label. Population in billions, this is my correct y-axis label. It's a straight line. Those are the plotted points. And I got a descriptive title up here. So if you did anything close to that, give yourself a point for that. And another conversion, we are going from kilograms to milligrams, which means we're going 6 spaces to the right. I go 1, 2, 3, 4. I run out of numbers, which means I need to add 2 zeros, and I end up with 7,800 milligrams. I go from larger to smaller. Therefore, my number should be larger. Okay, that's all the review we got on the metric system. If anybody does need some help with the metric system or scientific notation, and we have time at the end of class after I'm done talking to a couple students, we can do a little bit of review at the end of the class. Okay, so we're now up to, this is 3, 6, 7. We're up to 17 possible questions. If you're anywhere close to 15, you are killing it. All right, here we go. Scientific notation and the scientific method. Why are numbers put in scientific notation? What is the best reason for using scientific notation? You're going to find those in your scientific notation notes. What is the process used to find answers to questions? What do we call that? You're going to find this in the scientific method class notes. If you know one or both of those answers, put your hand up. I remember exactly where I was when I heard that Michael Jackson had died. I was hanging out with a buddy in Hayward, which is just east of Oakland, getting ready to go out to dinner with he and his wife. And we heard on the radio that Michael Jackson had died. I remember exactly where I was when I heard Prince had died. I was on the Avid College Tour field trip. And one of the kids on the bus was a huge Prince fan, and she was sobbing and bawling. And I had my iPod with me with like 300 Prince songs on it, so we played Prince for a little while. Prince is my wife's favorite artist. Okay, any more hands going to go up before I show you guys the answers? If you know even one of these two questions, put your hand up. And we got about a little bit more than a third of the class. All right, here we go. The main reason why we put numbers in scientific notation is that some numbers are very large and some numbers are very small. It's not that anybody that speaks any language can read it. That is a reason, but it is not the best or most important reason. Most important is that some numbers are big, some numbers are small. The scientific method is a process used to find answers to questions. That is the first thing you wrote down in the scientific method class notes. All right, here we go. So we're up to 19 total points at this juncture. Okay, put 67.89 into scientific notation. Take this number that's in scientific notation and convert it back to normal notation. Sorry, I am a huge Smiths fan.
I love the Smiths.
They are awesome. I actually met Johnny Marr in San Francisco at a show. Signed my CDs. My wife couldn't go to the concert because she was sick. Signed one of my CDs just for her. Never met Morrissey, though. Okay. Scientific notation. You either know how to do it or you don't. If you don't and you want to learn it, I can stick around for 10 or 15 minutes after class today and help you. Or just go watch some videos, because the videos are going to have practice built into them. So if you don't want to be stuck with me, go watch some videos. There will be only 2 questions out of 32 that deal with scientific notation. So, if you're not interested in committing it to memory, you'll miss those questions, or you can guess, I suppose. Okay, 5 more seconds before I show you the answers. All right, 5, 4, 3, 2, 1. All right, put them up. Okay, here we go. 6.789 times 10 to the 1. Okay, so here's what you do. The decimal always goes after the first number. To get back to normal notation, if I have to go to the right, it's going to make the exponent positive, and the number of spaces I have to move to get back to the original number is equal to 1. All right? Okay, so this is in scientific notation. It is a positive exponent, which means the decimal is moving to the right, and the exponent itself tells me how many spaces to the right. 1, 2, 3. We should get 7784.3. Again, if you want some practice with me at the end of the class, stick around or go to YouTube and find some videos on how to use scientific notation, and it'll give you practice opportunities as well. All right, here we go. 3 questions here. First one is worth 2 points. The 6 steps of the scientific method in order. 6 steps of the scientific method in order. That's worth 2 points. And then 1 more scientific notation question. Okay, about 15 more seconds. Remember, the 6 steps in the scientific method, the last step has 2 possibilities, but it's still only 1 step. All right, 5, 4, 3, 2, 1. All right, here we go. Okay, here are the 6 steps. Identify the problem, form a hypothesis, create the experiment, which is your procedure, do the experiment, that's when you collect the data, analyze the data. If the data supports your hypothesis, you communicate your results. For you guys, that means writing a conclusion for a lab report. If the data do not fit your hypothesis, you're going to modify the experiment. But before you do that, you're probably going to go back and do it again just to make sure you did not make a mistake. Okay. So on the test, you're just simply going to have to recognize which 6 are in the correct order. All right. So obviously, if one of the choices starts with do the experiment, don't pick it. Okay. Limit your choices to the ones that start with identifying the problem. Okay. Another scientific notation. Remember, the decimal always goes after the first number. Okay. The decimal is here, which means I'm going to the right. That makes my exponent positive, and it moves to the right 1, 2, 3, 4, 5, 6 spaces. And that's what makes it 6. Okay. All right. Okay, how many points are we up to? Bump, 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 bump. That's about 3 times 4 is 12, 15, 17, 19, 21. We're up to 24 total points. If you're anywhere close to 20, killing it. Good job. All right, here we go. So this has a question about an exercise lab. So we're not going to count this question. This is going to be a 1-point question. In the mineral density lab, what was the independent variable? What was the variable that I changed or that you would have changed? Remember, the mineral density was the dependent variable. What was changed that influenced the mineral's density? 15 seconds. Yeah, so after the Smiths broke up, Johnny Marr had a solo band called Johnny Marr and the Healers. And actually the bass player was a bass player of one of my other favorite British bands. And me and my buddy went and saw him in San Francisco and met Johnny Marr and met Alonza. And I got some of my Smith CDs signed. It was cool. All right, 5 seconds. 4, 3, 2, and 1. Okay, the dependent variable, the only thing we changed was the mineral type. Okay, remember we switched it from galena to quartz. Okay, just to give you guys an idea of, we still might do it at the end of the year, but one of the reasons why I really encourage kids and families to support Science Boosters is they give us access to extra money to use in the classroom. And I've got these tools. They're called sphygmomanometers. They're basically blood pressure gauges and heart rate monitors, and they're electronic. They're really cool. And I bought a class set of them with Science Booster money. But what you guys do or would have done in the exercise lab is you get to determine a type of exercise you're going to do, and you can compare male versus female. You can compare in-shape female versus out-of-shape female, in-shape male versus out-of-shape female, football player versus soccer player. There's lots of ways that you can actually change the independent variable. But unfortunately, because we're not in the classroom and we don't really have access to that gear for you guys to use, we didn't do it. But hopefully we have time at the end of the year to do the human physiology lab or the human physiology unit. And if we do, we'll definitely do this lab. All right, here we go. Whoops, my bad. Let's try this again. All right. There we go. Okay. My bad. All right, here we go. The metric system is based on a blank that corresponds to a certain kind of measurement. Hint, hint, wink, wink. It's in the middle of the grid. During an experiment, measuring the length of an arm or leg in centimeters and recording the data is what type of data? Sketch a quick bar graph and label the x-axis, y-axis, location of the title, and where the bars or data would be found. Give you guys about a minute to work on this one. As soon as you have at least 3 or 2 of those things, and you know that you have them right or you think you have them right, raise your hand. You will not have to draw a histogram. You will have to look at a histogram and determine if everything is in the right place or if everything is there. So starting on Monday, we will no longer be listening to music that starts with B. It's time to move on to the C's. And boy, it was really hard for me to pick 7 CDs out of my B's because I have over 100 CDs that start with B. I have more than that start with C. So I got my 7 CDs narrowed down to the following: Curve, Phil Collins, Crosby, Stills, and Nash, Crosses, it's the lead singer from the Deftones, John Coltrane for the jazz lovers, Coheed and Cambria, Chicago, the Catherine Wheel, and Chapter House, and Johnny Cash. So I've got 10. I've got to cut 3 of those. It was really, really tough. I'm a big Coldplay fan. Coldplay didn't even make the cut. I'm a big Cars fan. Cars didn't even make the cut. It's a difficult job, but somebody's got to do it. Okay, about 10 seconds. All right, 5, 4, 3, 2, 1. All right, here we go. Okay, so the metric system is based on a base unit. That's the easiest way to remember that. It's based on a base unit, and we're talking meter, liter, and gram. And the base unit is in the center of your grid. Anything measured with numbers and units is quantitative. And here is an accurately labeled bargram or histogram. The y-axis is the vertical axis. The x-axis is the horizontal axis. The bars or the data are found in the graph, and the title always goes at the top. All right, last question, or last set of questions. During the microscope experiment, we didn't do a microscope experiment, but you learned the things that you would have learned in the microscope experiment. What 2 things happened to the letter E when you looked through the lens? During the same lab, this is a tougher one because not all of you guys picked this up. During the same lab, what 2 things do you need to do when switching from low to high power? Again, if you don't know the answer to these questions, don't worry about it. These questions are not on the test, but some of you guys do know all 4 things for this question. Okay, about 15 seconds. Again, if you know any of the answers to this slide, put your hand up. All right, I got about half the class with a hand up. That's good. Again, you're not going to find this in your notes. You're not going to find this. You might find it on the movie worksheet for this activity, but you're not going to find it in your notes or the study guide because it's not on the test. All right, here we go. Okay, so the letter E was reversed and upside down. So it was upside down vertically, and it was upside down horizontally, or reversed horizontally. Whenever you go from low to high power, you only need to use the fine adjustment to focus on the object, but then usually you will have to increase the light. Things get darker when you go from low to high power. So you'll need to adjust what's called the iris diaphragm that's underneath the stage on the microscope. And usually it's only the refocusing under the fine adjustment. All right, so we're not counting these 4 points. So what do we got? 3, 4, 5, 8, 10, 12, 13, 16. This was only 3, 19, 22, 23, 24, 27, 28, 29. So there should be 29 questions, maybe 30. If you're anywhere close to 25, you're in great shape. If you're over 25, take a couple days off. Okay, take a couple days off. Hit it again on Sunday. Review your study guide with the video that's going to be on Google Classroom. If you are close to 20, you're getting there. Okay, that's about 2/3. Remember, this is harder than the test is going to be, because the test you will see the answer. You just got to pick the right one. If you are less than 15, you got some work to do. Okay. And if you're less than 10, you got a lot of work to do. Okay. And maybe you weren't even keeping score. Okay. So that is it for the presentation. Let me stop this share. Let me stop the video. Give me a second.